In August 1609, Venetian rulers climbed the bell tower of St. Mark's carrying a new kind of weapon. It was not a cannon, a blade, or a map. It was a narrow tube containing two carefully shaped pieces of glass. Raised toward the lagoon, it pulled distant ships closer. Sails that would normally appear as pale marks on the horizon could be examined before they reached the city. For a republic built on trade and naval power, this was not a curiosity. It was information gained before an enemy, merchant, or rival port could react. The man demonstrating the instrument was Galileo Galilei. He had not invented the telescope, although history often remembers it that way. Crude spyglasses were already circulating in Europe. What Galileo understood was that better glass could create better power. Venice rewarded him with higher pay and permanent employment. Then he turned an improved version toward the night sky. The moon was no longer a perfect celestial sphere. It had shadows, ridges, and rough terrain. Jupiter had bodies moving around it. Venus changed phases. A material once used for beads and perfume vessels had become capable of challenging governments, careers, religious authority, and humanity's place in the universe. Glass had learned to see too far. Soon, it would also learn to see things too small for any human eye. Today, glass is so common that it nearly disappears. It sits in windows, bottles, cameras, laboratories, cars, hospitals, and screens. We notice the view, image, liquid, or light. We rarely notice the material controlling how each reaches us. But for most of human history, transparent glass was neither ordinary nor cheap. It was difficult to make, easy to ruin, expensive to transport, and often cloudy, colored, or distorted. The earliest glassmakers were not building windows into the universe. They were trying to create something beautiful, durable, and strange. More than 4,000 years ago, craftspeople in Mesopotamia and Egypt learned that certain mineral ingredients, combined under extreme heat, could become a substance unlike ordinary stone. It could be melted, colored, shaped, and hardened. Sand-like materials entered a furnace and emerged blue, green, yellow, or red, imitating turquoise, lapis lazuli, and other precious stones. Beads and inlays traveled through elite trade networks. Vessels held perfumes, oils, medicines, or ritual substances. Glass signaled that someone possessed wealth, specialized labor, and access to distant materials. It was not transparent because transparency was not yet its central promise. It was artificial stone, manufactured mystery. But the story of its invention became trapped inside a far simpler legend. According to the Roman writer Pliny the Elder, Phoenician merchants once landed on a beach and built a cooking fire. Unable to find stones to support their pots, they used blocks of mineral cargo. By morning, the heat had fused the material with sand and created glass. It is a perfect origin myth: sailors, fire, accident, discovery. It is also almost certainly not how glassmaking began. A beach fire could not easily control the conditions needed for developed glass. The truth was slower and more human. Glass likely emerged from generations of experimentation with ceramics, glazes, pigments, mineral mixtures, and increasingly powerful furnaces. Craftspeople learned how heat changed matter because their work forced them to observe failure. Batches cracked. Colors turned wrong. Furnaces cooled too quickly. Impurities ruined the result. A small change in temperature or composition could destroy days of labor. The myth remembers one lucky fire. The real history belongs to unnamed workers who spent centuries learning how to make fire obey. Their knowledge was valuable because few could reproduce it. Recipes could be guarded. Skilled labor could be moved by rulers or captured by conquest. Useful things have a dangerous destiny. Eventually, someone tries to own them. Yet early glass remained slow to shape and expensive to produce. To become a system, it first had to become faster. That began when a worker placed molten glass on a hollow pipe and breathed. Glassblowing appeared in the Eastern Mediterranean around the 1st century before the Common Era, and it changed the economics of glass. A craftsperson could gather a glowing mass, inflate it, rotate it, stretch it, and shape a vessel far faster than older techniques allowed. Breath became a manufacturing tool. Under Roman rule, workshops multiplied and glass traveled through cities, ports, military routes, and households. Bottles held oil, wine, sauces, medicines, and perfume. Cups competed with pottery and metal. Merchants could display what they sold. Buyers could inspect contents without opening the container. Glass resisted odors, and broken pieces could sometimes be melted again. Its scale expanded from palace ornament to daily utility. But abundance hid a human cost. Furnace workers operated near relentless heat. They inhaled smoke, handled heavy tools, and depended on timing precise enough that seconds could separate a usable vessel from a collapsed one. The empire enjoyed the transparency. The worker lived beside the fire. Still, glass had crossed a threshold. It no longer existed only to resemble something precious. It had become a practical tool for containing, preserving, selling, and measuring the material world. The next problem was architectural. Humans wanted light inside their buildings without inviting in rain, wind, cold, dust, animals, and thieves. To solve it, glass had to become something it had rarely been: flat. A glass window seems like an opening, but it is actually a controlled barrier. Early panes were small, uneven, expensive, and distorted. Some were cast. Others were blown, cut, opened, and flattened. Looking through them could bend streets, stretch faces, and blur movement. Yet even imperfect glass transformed a room. Light could enter while weather remained outside. In Roman buildings, later churches, palaces, workshops, and wealthy homes, the window began separating physical access from visual access. Stained glass turned daylight into religious theater. Biblical scenes appeared above congregations who might never read the texts. Light became doctrine. In domestic spaces, a person could observe the street while remaining protected behind a transparent wall. In shops, goods could be displayed without being touched. As panes grew larger and clearer, cities changed their faces. Interiors became brighter. Storefronts became invitations. Wealth became visible through the size and quality of windows. Poorer households still lived behind smaller openings, shutters, cloth, horn, or cheaper panes. Transparency was never distributed equally. It required fuel, labor, specialized furnaces, and reliable production. Glass did not remove the wall. It created a wall that organized visibility. It decided who could look out, who could look in, and what could be displayed without being reached. Then another form of glass turned that structure inward. Instead of showing the world beyond the wall, it showed the viewer's own face with unsettling clarity. In Renaissance Venice, especially on Murano, glassmaking became a protected industry. Venetian artisans developed refined glass and mirrors desired across Europe. The state understood that the real treasure was not the finished object. It was the knowledge inside the workers' hands. Glassmakers received privileges, yet authorities tried to stop them carrying techniques to rival courts. A craftsperson could be honored and restricted at the same time. The clearer the glass, the more dangerous the knowledge. Mirrors revealed another kind of power. Earlier humans had seen themselves in dark water, polished metal, or imperfect reflective surfaces. High-quality glass mirrors made repeated self-examination easier, sharper, and more private. A noble could inspect clothing before entering court. A merchant could judge the image shown to clients. Grooming, posture, beauty, and social performance became more measurable. The mirror did not invent vanity, but it gave vanity better equipment. It also created a quiet reversal. For most of life, a person sees other faces directly, but never sees their own in the same way. Glass turned the self into an object of observation. Appearance could be rehearsed. Identity could be adjusted before entering public view. The window had made the outside world available from a distance. The mirror made the self available from a distance. But the most intimate optical revolution was still ahead. For millions, aging did not first arrive as pain. It arrived as words becoming impossible to read. Before corrective lenses, failing close vision could end a working life. A scribe who could no longer distinguish letters lost access to his craft. A merchant unable to read accounts became dependent on others. A scholar might hold decades of knowledge yet be unable to read. Reading stones and early spectacles changed this by bending light before it entered the eye. For the first time, glass did not merely stand between a human and reality. It corrected the image itself. Spectacles returned detail to aging eyes. They extended careers, protected literacy, and kept accumulated knowledge active for longer. This was not a minor convenience. In societies increasingly governed by records, contracts, religious texts, correspondence, and calculation, clear sight meant continued participation. Lens grinding became a specialized trade. Workshops experimented with curvature and polishing. Guilds formed around spectacles and other optical instruments. Yet the same imperfections that made one pair of lenses uncomfortable could become disastrous when lenses were combined. Distortion multiplied. Colors separated at the edges. Images blurred. The craft had to become more precise because the ambition was growing. Correcting the eye was only the beginning. Once lens makers placed glass in deliberate arrangements, they created machines that extended vision beyond the scale of the human body. The telescope carried sight outward, and the microscope drove it inward. Together, they made the naked eye seem suddenly incomplete. When Galileo pointed his telescope upward, he did more than collect strange sights. He entered a battle over who had the authority to describe reality. Ancient texts, religious interpretation, mathematics, and observation no longer fit cleanly. The telescope introduced a new witness, but it was a witness made of imperfect glass. Rivals could claim the instrument lied. Some observers could not see what Galileo reported. Others lacked telescopes powerful enough to confirm it. The discovery of Jupiter's moons was therefore not only astronomical. It was a struggle over instruments, patronage, reputation, and repeatability. Galileo even named the moons in honor of the Medici family, tying celestial discovery to earthly protection. Vision had become political again. Meanwhile, another instrument exposed a universe hiding in dust, water, plants, and tissue. In 1665, Robert Hooke published Micrographia, filling its pages with enlarged images of fleas, needles, cork, and familiar objects transformed into alien structures. A tiny insect became an armored machine. A point that seemed sharp appeared blunt and damaged. Cork revealed compartments Hooke called cells. But microscopes created fear as well as wonder. Early lenses produced halos, false colors, blur, and warped forms. Scientists could not always know whether a strange feature belonged to nature or to the glass. This was the deeper revolution. Glass did not simply reveal the invisible. It forced science to invent methods for deciding when vision could be trusted. By the way, if you have made it this far, you probably already see the pattern. This channel is not really about objects, it is about the systems hiding inside them. So if that kind of history interests you, subscribe. Now, back to the strange part. Revealing the invisible was one thing. Turning it into evidence was another. Microscopy became more reliable as lens makers reduced distortion and researchers learned to compare observations, repeat experiments, improve lighting, and separate optical artifacts from real structures. In the 19th century, improved achromatic microscopes reduced colored fringes and gave medical researchers greater confidence in what they saw. Laboratories filled with transparent vessels, flasks, tubes, slides, pipettes, jars, gauges, and chambers. Glass allowed reactions to be contained while remaining visible. A scientist could heat a substance, watch it change, measure it, isolate it, and repeat the process. Medicine increasingly depended on things no unaided eye could confirm. Cells, tissues, parasites, and microorganisms entered diagnosis and research. Yet the authority of the image did not remain inside laboratories. Photography transformed light into a record. Lenses focused a scene, and glass plates helped preserve it. Faces could survive death. Battlefields could be carried into homes. Police, doctors, governments and courts gained images that seemed to speak for themselves. But every image had a frame. Someone chose where the camera stood, when the exposure began, what was included, and what remained outside the glass. Seeing became proof, but proof became an institution. Industrial glassmaking completed the transformation. Furnaces grew larger. Chemical compositions became more controlled. Sheets became flatter, clearer, stronger, and cheaper. Specialized glass resisted laboratory heat, machine pressure, and vehicle impact. Greenhouses captured sunlight and altered growing seasons. Windshields made faster transport possible while protecting drivers from air and debris. Cameras entered journalism, advertising, war, medicine, family life, and surveillance. Telescopes became observatories. Microscopes became standard equipment. Fiber optic strands carried information as pulses of light across oceans and continents. Then glass returned to the hand in a new form: the screen. A window shows what physically stands beyond it. A screen can show anywhere, anyone, or anything while hiding who selected the image and why. A phone's glass appears passive, but behind it are systems ranking attention, measuring behavior, selling ads, recording location, and deciding what arrives next. We look through glass to understand reality, yet increasingly reality is organized before it reaches the glass. The material that once helped an aging reader recover a sentence now delivers billions of sentences chosen by machines. The mirror that reflected a private face has become a camera-facing surface where identity is edited, displayed, compared, and judged at global scale. The object has not changed as much as the system around it. Glass began as manufactured mystery, a colored imitation of precious stone. It became a vessel, then a wall, then a mirror, then a lens. It helped rulers see ships before they reached the harbor. It returned words to failing eyes. It exposed mountains on the moon, moons around Jupiter, cells inside cork, and organisms moving through drops of water. It gave laboratories transparent control over matter and gave institutions permanent images of people, places, and events. Each improvement seemed to remove a limit: distance, darkness, age, scale, memory. But every limit removed created a new form of authority. The person with the clearer lens could see first. The institution with the better instrument could define what counted as evidence. The company controlling the screen could decide what millions saw next. Glass did not only show us more of the world, it changed what we were willing to call real. For most of history, seeing meant standing close enough. Glass broke that rule. The invisible did not suddenly appear. We built a material that allowed it to enter human history. And now, after 4,000 years of learning to see through glass, much of the world sees us through it as well. Subscribe, like the video, and tell us in the comments which ordinary material, invention, habit, or hidden system should be uncovered next.